In this session, we are going to discuss about the different models proposed by different scientists regarding the structure of atom. Next, we are going to look at Sir Thomson's model of an atom. After the electron's discovery, Thomson tried to draw the structure of atom. Let's see. Electrons are evenly distributed. As you can see in this diagram, that he thought that the atom to be consisting of electrons negatively charged surrounded by a positive sphere. This structure looks like plum pudding model, that the electrons, where the electrons are considered as plums and the positive sphere as pudding. That's why this model is also called plum pudding model. But this model failed as it could not explain the stability of an atom. An atom can only be stable if it has equal positive and the negative charges. But here he did not explain about the distribution and arrangement of the electrons with respect to the positive sphere. He also considered the mass of the atom to be evenly distributed, which is not the case. Later, Ernst Rutherford gave a new picture of the structure of atom by his alpha particle scattering experiment and proposed the structure of atom. He set up an apparatus like this in which he bombarded the alpha particles on a very thin sheet of gold foil. What are alpha particles? Alpha particles are nothing but the helium particles, and they had 2+ charge on them. So he bombarded these alpha particles on thin sheet of gold foil. It was noticed that most of the particles passed straight through the gold foil without any deflection. Instead, some got deflected as they passed through, and some bounced back at 180 degrees. From these observations, he concluded that the positive mass of the atom must be concentrated in a very small area, as most of the particles didn't show any deflection, which means that most part of the atom was empty. That's why the particles didn't reflect it back. Most of the atom space was empty, as we just discussed. The electrons revolve around the nucleus in the orbits. This model of atom also failed as he could not give the exact location of the electrons. Moreover, when he explained that the electrons were charged particles and they were revolving around the nucleus in a circular motion, it could mean that they will lose energy and these electrons would fall into the nucleus, and thus this atom will become unstable. But that is not the case. Atom is very stable. Also, Rutherford could not explain the colored spectra which was obtained during this experiment. Now, the next is that Sir Neil Bohr also composed a theory which focused on the outer part of the atom, which is outside this nucleus. He created the first model that considered the phenomena of absorption and emission of the radiations. The theory he proposed is called as Bohr's theory. Bohr's theory says that negatively charged electrons revolve around the nucleus in well-defined orbits or shells, and each shell having a definite amount of energy associated with it and associated with its electrons. Therefore, these shells are also called energy levels. As the radius of the orbit increases, the energy of these orbits also increases. These shells are also known as K, L, M, N, and so on shells, starting from the closest to the nucleus. Look at this diagram. An electron can jump from lower energy level to the higher energy level by absorbing some amount of energy. Now this energy is given by an equation which is here. This constant is called Planck's constant, and this is the frequency of the radiations emitted. You will study about this equation in the higher classes in details. Similarly, an electron present at the higher energy level can come down to lower energy level by losing energy in the form of radiations. Because if the electron is coming to the lower energy level, which has lower energy as compared to the energy of the higher energy level in which it is present, it has to lose that much of energy and make its energy equal to the energy of the level in which it is coming. The amount of energy absorbed or emitted is given by the differences of energies associated with the two levels, which means the change or the emission of energy is represented by this. This means change. It is called as delta. This change in energy will be equal to E2 minus E1, where E2 is the energy of that energy level where the electron is going and E1 is the energy from where the electron is coming. This theory helped us to look through the atomic structure with greater clarity and accounted for the stability of an atom. Meanwhile, a problem arises that the number of electrons and protons did not match with the calculation of masses, which initiated the discovery of third particle that is called neutron. Sir Chadwick proceeded with the bombardment of alpha particle with beryllium sheet, which emitted a stream of radiations. These radiations remained unaffected in the presence of electric or magnetic field, and these are called neutrons. These particles did not carry any charge. With this, we have completed the structure of atom. With this, we have come to the end of this session where we have discussed different models of the structure of the atom. In the next session, we will discuss about atomic structure, atomic mass, and mass number. Thank you.